As part of the topic of respiration, and in particular aerobic respiration, I want to take you through now with this video the link reaction. You should have already studied glycolysis. If you haven't already, please watch that video on glycolysis. And just recap yourself on the products of glycolysis. You've got ATP produced, you've got reduced NAD, and for our next step, we need to know what happens to the pyruvate that is produced. Now here's a reaction showing the link reaction. You've got pyruvic acid on the left. That's just another name for pyruvate. You can see it's just come from glycolysis, glucose at the top. And it looks a little bit more complicated. Its product is acetyl-CoA. You can see that on the right hand side. CoA stands for coenzyme A, but you've also got a couple of other things being added in. You've got NAD, the coenzyme NAD, and you've got coenzyme A, and we've got two products. We've got reduced NAD, which is labelled NADH there, and we've got CO2 produced, and that's what I want to focus on. It's actually this part of this reaction that you see now. That's the link reaction. So let's take it from the beginning. The actual site where link reaction takes place is the mitochondria. So glycolysis occurred in the cytoplasm, and this process occurs in the mitochondria, particularly the area in the middle, which is called the matrix. Now glycolysis, let's just recap that again. You have the final products of ATP and NADH, or reduced NAD, and pyruvate, which are 3 carbon structures, and of course we get 2 of them, 2 per glucose molecule. Now they get transported into the matrix of the mitochondria using a transport protein, a symport transport protein. It's symport because it also transports hydrogen ions at the same time. Right, so let's look a bit closer at the link reaction in the matrix of the mitochondria. Starting from the beginning, we've just had the pyruvate transported in to the matrix with those symport proteins, and that undergoes a reaction. We have 2 inputs here. Coenzyme A is going to join to pyruvate, and if it joins to pyruvate, something is going to have to be given off. At the same time, NAD, the coenzyme NAD, is going to remove a hydrogen, so it's going to oxidize pyruvate and become reduced itself. So these 2 coenzymes join the reaction. NAD becomes reduced NAD, but what's given off when coenzyme A joins pyruvate is carbon dioxide. Now that's really interesting because if you recall from your GCSE years, the chemical or the word equation for aerobic respiration, you realize that CO2 is given off, and if you know your balanced equations, you'll understand that there's 6 molecules of carbon dioxide given off. So here we go, here's the first one. So we're starting to understand now the aerobic respiration equation. Right, so this carbon dioxide is removed. That's called decarboxylation. And we've had the dehydrogenation using NAD. What's remaining is this acetyl coenzyme A. Acetyl coenzyme A. It's now only 2 carbons because carbon dioxide has been given off. But you can see that the coenzyme A group is added on. So big process going on here. Pyruvate is converted to acetyl coenzyme A. Carbon dioxide is given off, decarboxylation, and more NADH, or reduced NAD, has been made by dehydrogenation. So NAD has become reduced. Now a bit of maths for you. Please remember, we started off with 1 glucose molecule in glycolysis. That means that was 2 pyruvates. Therefore, in this link reaction per glucose molecule, you will get 2 reduced NAD, 2 times CO2, and 2 acetyl coenzyme A's. Now the acetyl coenzyme A will continue into the next stage of aerobic respiration, which is the Krebs cycle, which I'll also have a video for you to watch. So coming back to the reaction which I had at the beginning of this video, there it is. Hopefully it's a little bit less complicated for you now. I didn't mention the enzyme there, Pyruvate Dehydrogenase. That does exactly as its name suggested. It takes the hydrogen from pyruvate and it puts it onto NAD, or reduces NAD